All right, guys. So we are going to write a program for this part right here. We're going to create toolpaths. There's different ways to do this. This is going to be a part off in this example. So you're going to have a face, a turn the OD. We're going to cut it straight. Then we're going to cut this little 45-degree right here. Now I'm going to show you all both ways because this is going to be a part off job. But I'm also going to show you all how to actually part off with this 45-degree right here. It's really simple. It's literally a checkbox. Um, in this case, because it's a thread, I wouldn't part it off right there because you could risk pushing a burr into the thread, and when you actually screw the part in, it could have a burr, right? So, but I'm going to show you all both ways to do it. So we're gonna chamfer it with a tool, and we're also going to chamfer it with part off too. I'll show you all that as well. So we're going to have a thread, we're going to drill it, and we're going to board the ID. One tip I want to give y'all is anytime you're doing lathe parts, this section analyst, if you come over here to inspect section analyst, you could cut the actual part in half right here so you can see the inside, right? But anyways, with that said, we're gonna rough the ID out, something that looks like that. We're gonna come in here, cut this little chamfer. We're gonna do an ID finish and then the actual part off right there. All right, so the first thing we're gonna do is we are going to go create a setup. So I'm gonna click right here on the left side and go to setup, and we're gonna have a turning. And let's see, make sure your safe reference. We'll put that on WCS, offset 1.5 inches. I'm gonna go to my stock. My stock is we'll say 3.75, and we'll say we're 1.5 inch long. Okay. Uh, Sometimes you can be running a big bar. Whatever your stock size is, go ahead and put it there. Okay. If it's going to be 24 inches, put 24. Right. So you have a big bar in your lathe, but this is kind of a large diameter, so you may not have a spindle board that big. But anyways, that's what you would do. So I'm going to make this one 1.5. We're going to say we have one piece to make, and we have just enough material right here to chuck up on to actually come in here and cut this and part it off. So I'm going to hit OK. I'm going to come over here, and I'm going to name this op 1. There isn't a second op, but we'll just name it op 1 just because. Okay, so the next thing we're going to do is we are going to create a facing operation. I like to use turning profile roughing, and the reason why is if you actually use a turning face, it doesn't output a G72 code, and I like the G72 CAN cycle. So we're going to go ahead and click turning profile roughing, and we are going to select our tool. So I'm going to go over here, I'm going to add a tool. Now, I already have a tool in my tool library, but for this example, so you know how to make a tool, we're going to go ahead and make a tool real quick. So I'm going to go click on Turning General, and let's make this CNMG 432. My insert is going to be a CNMG 432. Right? Cutting data. We're going to say this is 4140 heat treated. Let's go 650 RPM. I'm sorry, surface footage. And so our feed rate. Now we're not going to have a finish pass. We're just going to face it and be done with it, right? So let's go 10,000. I would normally go faster, but we want to have some kind of finish on there. I'm going to hit OK. I'm going to hit select. So I have my tool right here, my maximum RPM. Let's go 1250. And all right, so on our geometry tab, my front is going to be stock front because that's where you want to start facing, is where the stock is. And your back is going to be on model front because that's where you're going to stop at when you get to the front of the model, right? So I'm going to go to radii, And let's do a stock OD, add 50 thousandths. If your material is going to be running out, you can increase it, make it 0.1. You know, sometimes you may have a saw guy that cuts crooked parts and your part might be out. So you don't want to, sometimes it helps to offset that on the face a little bit. Anyways, outer radius, we're going to say stock OD, inner radius, stock ID, right? So my cycle, we're going to put this on vertical passes. That's how we get our fade. Okay. So we want to cut down, right? That's what a facing operation. You want to check this box right here. Use can cycle. That's going to output your G72, right? Maximum depth of cut. I'm going to go 50 thousandths on this. And stock to leave. Now we're just going to cut it and be done with it. So we're going to go ahead and just leave no stock, no finish, just a face. And this is my my linking tab. I use Safe Z. My approach X is clearance X, and I use a 25 thousandths clearance. Okay, so I'm gonna hit OK, and here's my face operation. So I'm gonna name this face. Okay, so the next operation is going to be a turning roughing. So I'm going to go to turning profile roughing. I'm going to use the same tool. My maximum RPM is going to be 1250. And I am going to go 12 thousandths feet rate. You know what? Go faster. I'm going to go 14. How about that? Okay. So our front is going to be the model front. This is the geometry tab, by the way. So front, I'm going to put it on model front. Our back, we're going to go model back. Now, this is where you have to figure out how you want to do this. What is the width of your part off tool? Okay. In this example, I'm going to use a 1/8 inch wide part off tool. So that is 0.125 inches, right? So what I want to do is I want to turn back further than an 1/8 inch because I need clearance, right? So what I'm going to do is I'm going to go 150 bends. I'm going to go minus 0.15, right? So that gives me an extra 25,000 clearance. And I'm going to go radii. We'll just put this at 0. So we're going to go stock diameter, and inner radius. You leave that stock ID, even though you're not actually cutting that far down. The software will stop the toolpath at VOD diameter. So that's a little tip. And this is great to know if you're going to be automating toolpaths or using templates. It speeds things up. You can have basically the same settings every time and just spit out toolpaths, and whatever the shape of the model is, it will make it correctly. Okay, so that is one thing to get used to, right? So I'm gonna go to my passes tab. I'm gonna use horizontal. I'm not gonna allow grooving. We have this 45 degree right here, but we can't get that 45 with this tool. Okay, so we're gonna cut it straight. I'm going to save 10 thousandths X for finish and 2 thousandths on Z. And linking, let's see, we'll do safe Z X, we'll do clearance X. And clearance, I'm going to do 50 thousandths. All right, so I'm going to hit OK. And here's my toolpath right here. Right? So now, so you have this 45. You could cut that with a 35 degree. I'm going to be honest, a lot of times I cut that with a 35 degree. Today, we're going to use a part off. So either way, whatever you want to do. But if you do this with a 45, what you're going to do is use a 40. You're going to use a 35 degree insert, and your front geometry is going to be on this edge, and your back geometry is going to be on this edge, plus a little bit of clearance. You got to get the radius. You got to be able to compensate for the radius of the insert. Okay, so if you notice our OD rough toolpath, it has a warning. We're getting a X clearance trim at the clearance radius. Okay, so I'm gonna right click on it. I'm gonna edit. And we're going to go to the radii tab, and let's add 100,000 to the offset, right? So we're doing stock diameter, 100,000. Now, look at the rapid moves right here. See how they're not straight across? Let's change that. Kind of weird. Let's go ahead and let's add 50,000 to the outer radius there. And that straightened up up. All right, so the next thing we're going to do is we are going to get this back chamfer right here, right? So what I'm going to do, this is what I like to do. So I like to come over here, duplicate my OD rough, and we'll make this OD rough back. And we're going to edit, and I'm going to switch a tool. So we're going to go ahead and create a tool. Now, I already have a tool created, but we're going to make one so y'all can see the process. So I'm going to go over here, go to plus sign, and I'm going to type in turning general. And we're going to make this a VNMG 332. My shape is going to be V. My relief N. Tolerance is going to be M. Cross section is going to be G. Insert size 3. Thickness 3. And my corner radius is going to be a 2. Right? So VNMG 332. Right? Surface footage, make the surface footage 650, and we're just roughing, so 10 thousandths will be fine in this case. Now I would normally go faster, but go ahead and select it. The way we're using this tool to come in and get that back relief, 10 thousandths would be fine. All right, so my geometry. So what I'm gonna do is my front, I'm gonna put it on selection, and I'm gonna select this edge right here. The back, I'm gonna leave the same. And I'm gonna leave it just like this for a set moment and show y'all what the toolpath right now, how it would generate. Okay, so the clearance, we're gonna leave this how it is right now. It's not right, but I'm gonna show y'all why. We're gonna jump over to the passes tab, grooving, allow radial grooving, and we'll put depth of cut's going to be 35,000. Okay. So I'm going to go ahead and hit OK. Now, you see how the tool is going way past the edge of this chamfer right here? We don't want to go down that far. And that is because we have it on undercut mode, but the radii is set down here to stock ID. So what I'm going to do is I'm going to put this on selection, and I'm going to select this edge right here. We're going to hit OK. Now notice the toolpath is the correct depth right there. And that's what you want to do. Now, remember, how far back you go past the model has to do with, is related to how wide your part off insert is going to be, okay? If you're using a 156, go 156 plus some, plus 10,000, 20,000. We're going to use an 1/8 inch part off, so we're going 150. So it's an extra 25, right? Anyways, that's the OD rough. Now I'm going to go and do the finish. So I'm going to select turning profile finishing, and we're going to use the same tool, so I don't have to change anything, except I'm going to change the feed rate. We'll make it 7 thousandths. All right. So my geometry tab, I'm going to go model front. The front's going to be model front, and the back is going to be it's going to be model back minus 0.15. Clearance radii. Let's see. Let's make this, make it 0.1. That'll be fine right there. Inner radius, I'll put this on selection. and I'm going to select this edge right here where the chamfer stops, or the chamfer ends. All right. So on the passes tab, the only thing I'm going to change is allow radial grooving. So a lot of times you can get by with the bare minimum. You don't always have to. You don't have to go and change every setting. Really, what you want to do is, well, I would suggest if you're just learning Fusion, select your tool and the geometry that you're going to cut and hit OK. Just see what it does. Okay. A lot of times it'll give you a usable toolpath. So you kind of want to get the bare minimum. And once you get used to the process, the workflow, what you want to do is basically there'll be times where you're like, well, I want the tool to actually come in and lead in straight and then come out. That's when you start actually going over the details of every input value. But anyways, let's hit OK, see what happens. That will work. Like this lead in right here. See how I was leading in at 45 degrees? Let's change that. So I'm going to edit. I am going to, I have my used fixed lead in distance. I have that checked, right? And with that check, the linear, let me open this so you can see it. The linear lead in angle, it's on 45. I'm going to put it at 0. Now notice when I put it at 0, the tool comes straight in, comes in and cuts. So let's name this toolpath OD finish. And I'm going to go ahead and simulate it. The tool's going to come down, feed in, feed back. And you always want to make sure that tool is actually going back far enough right there. And we are. And if for some reason it's not, or you ever have trouble on chamfers or any kind of bevel, what you want to change is this tangential extension on it's usually the back you need to change it on. This right here, it's usually on bevels where you have the problem. You feed up and then you stop and you come out. What happens, it doesn't basically when it compensates for the tool nose radius, the way the algorithm works, it doesn't always actually get everything. It'll leave like a burr or like a little bitty step, right? And what you want to do is add like an extra 10 dollars. In this case, I'm not going to worry about it. I'm going to hit OK. So that's my OD finish. And now, like I said earlier, it's a good idea to cut this back chamfer right here with a with V&MG 35 degree insert. And the reason why is because if you part it off, you could push a burr on there. Now, for the sake of this exercise, I am going to show y'all how to cut it with the part off. Okay, so just ignore this little chamfer right here, right? For the rest of the tutorial, because I'm going to show y'all both ways. I'm gonna have to, basically, we're going to have the part off tool come down, cut the chamfer. Okay, so next thing we're going to do is we're going to cut an OD thread. So I'm going to go to turning thread. I'm going to go ahead and select the tool. Now I already have a tool made, but I am going to make one just for you guys. I'm going to go to turning threading as my tool type. And let's just, there's a bunch of different types of threads. It can be a lay down, stand up. I'm going to be honest. Your major, your minor, your depth of cut, and your feed rate is the only thing that really matters. Right? So we're not really going to worry too much about thread. A lot of that stuff you can be figured out on the machine. It's not really going to affect the tool path too much over here. All right, so I'm just going to name this OD thread. Right, pretty simple. If you want to use a TNMA 43 stand up or a lay down insert, yeah, go ahead. Thickness. So normally you would have the Normally you would actually just measure that. Let's see. We'll keep it at three. I'm gonna be honest. A lot of it doesn't really matter. But what you would want to do is you would have the tool geometry in front of you, the tool, measure it, and kind of fill out the parameters as you go. Now, a lot of this is, for simulation purposes. It's not really going to affect the G code too much. So in that case, we're not going to really worry about it. But let's see, your width. Your width does matter. So it's got to be larger than the actual the lead, right? So we are going to do a 3.5 inch 8 OD thread, right? So 3.5 inch 8. So the lead is going to be 0.125. So our width is going to be greater than that. So we'll say it's 0.1875. Minimum thread, yeah, we'll put 0.014. Maximum thread, 0.1875. Yes, you're not actually going to use that, but we're just going to put that number because if you don't get this number correlated with the width, it'll error on you. And just to keep things simple, just make these two values the same unless you have the tool in front. Cutting data, spindle speed, we'll go 350. And tool number, we're going to let it just do default. So I'm going to hit OK. I'm going to select this tool. All right. So what I'm going to do now is I'm going to go to the geometry tab. The front. So the first thing we're going to do is we're going to click here on thread face, and I'm going to select top of that major diameter, right? Thread pitch, 0.125. Thread depth is going to be, thread height is 67 thousandths and 7/10, right? I find it easier or more accurate numbers if you round up and go up to 3 or 4 thousandths larger than the actual thread height. So 67 thousandths, let's just put 0.07. I also like to keep it a whole number. The reason why I like to keep it a whole number is when you go to your passes tab, it's easier to get a even depth of cut or you can get a whole number. But anyways, okay, so confinement. So the front, we have it's an 1/8 inch lead. So let's just make the front offset 0.125. Okay, so notice it's not actually 0.125 in the face of the part. It's actually 0.125 to the face of where the thread actually starts. So it's adding the distance to the chamfer. I really don't want that. So what I'm going to do is I'm going to put it in origin absolute and then have it at an 1/8 inch. And I'll also do the same thing on the back. I'm going to go to model back and go minus 0.125. Radii, I'm going to put it on selection. I'm going to select this major diameter right here. And I'm going to add 50 thousandths to it. Okay, passes tab. So remember, our thread height from this thread was 70 thousandths. All right, so say that I'm going to go 4 thousandths increments, right? So the step downs is per side. So if I go 4 thousandths, that's 2 thousandths per side. So 70 thousandths, which is thread height, divided by 0.002 is 35, right? So my number of step downs, I'm going to put at 35. And when I hit tab, notice my first pass right here comes out as 0.002. So basically, it's going to be in increments of 0.002 for each pass per side. So that's 4,000 diameter. Linking, Whatever default you have there will most likely work. So I'm gonna hit OK. And let's name that red toolpath. So I'm gonna name it 3.5-8 UN. And we're gonna hit save. All right, guys. So the next thing we're gonna do is we are going to drill this part. Now, if you look, the ID is 2 inches. Okay. I'm gonna say that I have a 1.5-inch drill. Now, it would be faster to drill something bigger, but for the sake of this exercise, I'm gonna have a roughing bore and a undercut bore and a finish. Okay, so we're gonna have 3 actual tool paths here, right? So with that said, I am going to make the drill smaller, so I have a reason to give you all an example for roughing bore. But anyways, so what I'm gonna do is I'm gonna go over here to drilling, and I'm gonna go select, and I am gonna create a drill. So I'm gonna go drill here, and this is gonna be an inserted drill. So I'm gonna say it's a 1.5 inch inserted drill. So it's gonna be 180 degrees, right? So with that said, what I'm gonna do is I'm gonna make the diameter 1.5 inch and the tip angle 180. Very important. And a lot of this we can leave default. I'm gonna jump over to the cutting data tab, surface footage. Let's go 400. And we're going to check this box right here, use feed per revolution. And my feed per revolution is going to be the 3000s. Post processor, we'll make it tool number 6 here. I'm going to select. I'm going to go to my geometry tab and face. I'm going to select this face right here. Then I'm going to jump over to the height tab. Now notice I'm not checking every detail in here. All right. Once you get familiar with Fusion, you'll kind of get to know what needs to be changed and what doesn't. A lot of times you just need a basic toolpath. You can kind of go in there and give it a depth, and give it a tool, and tell it what geometry, and bam, you have a toolpath. Now, when you start wanting to get very specific on how the tool is going to come in there, that's when all the other input boxes come in. But anyways, let's see. I'll make this. My clearance height is going to be 1.5 inches. My retract height is going to be 0.1. Feed height, 0.1. My top height is going to be 0. And my bottom height, I'm going to say whole bottom minus 0.25. Actually, let's make it minus 0.3. Now, a lot of times, depending on what your stock is, you may just want to drill through. Actually, let's just do stock bottom. Okay. We're going to part it off, but what that will do is I'm going to do stock bottom minus 0.1. What I'll do is it'll give your part, your bore and bar, chip evacuation, right? So you can stick a bar in there, and you're not going to worry about shavings building up. Now it's an 1.5 inch hole. You should have room, but good practice. Anyways, so the rest of this is fine. I'm just going to hit OK. And I'm going to name this toolpath 1.5 inch drill. Save it. All right, so the next thing we're going to do is we're going to create a boring bar, right? So I'm going to go over here, and I'm going to go to turning profile roughing. I'm going to select a tool. Now, I already have a tool, but I'm going to make one so y'all can see the process here. So I'm going to hit this plus sign, and I'm going to go to turning boring, right? This is going to be a, let's say, IDVCMT 221 3-degree lead. All right, so I need a 3-degree lead to to get underneath that 45. Okay, I'll show you what I'm talking about. So I'm going to go to insert. My shape is going to be V. My relief is going to be C. So VCMT. Insert size is 221. So 221. So thickness is going to be also going to be 2. Corner radius is going to be a 1. All right. So VCMT 221. Go to the holder. Now it shows a triangle insert right there. I don't know why it's doing that's Fusion. Welcome to Fusion 360. What you want to pay attention to is this graph of your tool. You can zoom in, you can pan out, you actually rotate this too. This is what you want to pay attention to. So when you make changes in here, you need to make sure you can verify that it's actually right, because you can easily make it out of proportion, and you'll see what I'm talking about once you start changing this stuff. But anyways, cutting width. So I'm gonna make this 0.6. My head length. One thing, I don't actually have the tool with me. So really, what you want to do, you want to get the tool, measure it, and then actually add these attributes to it. Anyways, head length, we'll leave it at that right now. 1.28. Overall length 6 inches. Shank. Let's go make it a 5/8. Try this out. Rotate it. See what it looks like. All right. Let's see what we got here. Okay, cutting data. Go to 650 surface footage. It's a small boring bar, so I'm just going to go 8,000 feet rate. Depth of cut. We're going to do 0.05, so 50 thousandths of an inch. Post processor. We're going to use the next number up, which is number 7. So I'm going to hit OK, and I'm going to hit select. Let's see, maximum spindle. We'll go ahead and bump this up. 1250. Geometry. So my front is going to be model front. My back, we're going to go model back. And let's see. So let's go minus 0.25. We're going to go a little further back, right? We'll try a quarter inch. We want to make sure we give ourselves room. So we're going to have that bar. We're basically going to have the bar go up in here and cut this undercut, right? So we want to get that chamfer in there. All right, so minus 0.25. We'll give that a shot. Outer radius. Let's leave it on stock OD there. Let's see what that does. Now I'm gonna be honest. What I usually do is I come over here. Oops. My outer radius. Actually select this. Now, really, I use template. Okay. So what you want to do is you really want to set this up, be using a template, and then you can just spit out programs. And we'll make another video on it. So I don't usually always go through every one of these details. Really, you want to get where you can write a program in like 5 minutes. Okay. And that can be done with templates. Once you get used to working with templates and you have a template for most common shapes and sizes, pretty quick, right? So normally I use a template. So forgive me if I'm a little rusty on some stuff, because usually I like to write programs fast, and actually going detail by detail and recreating tools is not exactly the fastest way to do it. But anyways, with that said, my outer radius is this diameter where that chamfer is. My inner radius is going to be select right here. And my clearance, I'm going to also select this ID, but I'm going to go minus 0.1. All right. Grooving, I'm not going to allow grooving yet. I'm going to check, use CAN cycles, and make sure this is right. So stock to leave, I'm going to leave 10 thousandths on the X and 2 on the Z. And let's just go ahead and hit OK. I think that's good right there. All right. So notice that I didn't get a toolpath. Okay. I kind of knew that was going to happen. I want y'all to walk through the process because boring bars, any kind of ID work like this on a lathe will it'll drive you crazy because if you don't have your settings for your clearance right, you're gonna have problems. So what we're gonna do, we're gonna go over here to your radii. So we go to the radii, and what we're gonna do is your clearance right here. Now remember, we drilled it with a 1.5 inch hole, right? So we want our clearance to be less than 1.5 inches. So all I'm gonna do is I'm gonna go to diameter, and we're gonna go 1.4, right? So I hit OK. Still don't have a toolpath, right? So what I'm gonna do is I'm gonna edit. I'm gonna go to this radii right here, and remember we selected this this diameter right here, right? Let's go minus 0.1. See what that does. All right, so here's your toolpath right here. Now, let's do that. So check this out. let me rerun that. All right, so let me check this out. So, whoo, testing, check. Okay, so check this out. So this isn't right, and I want y'all to see why. So I'm gonna right click right here. I'm gonna go simulate. Now watch the tool. So this tool's right here. Comes up. Look at that. Look at that path right there. It is taking that's more than 50,000. I mean, sometimes you're gonna want a heavy path. And notice it didn't get the material right there either. Right? So check this out. So what we're gonna do is we're gonna change the radii. Instead of that outer edge, we're gonna put this on stock OD. Now we're not actually cutting the stock OD, but notice it now gets that chamfer right there. Okay. Now I'm gonna be honest. I don't know why it didn't actually cut that chamfer. It should have cut that chamfer, but it didn't. And that's why it's a good idea to have your outer radius just leave it on stock OD. Because what you want to do is once you get your toolpath articulated to the way you want it, you want it saved as a template. And then you just pull up that template every time. You don't have to do all this work of entering all this input data. Really, all you do is use your template. Depending on the material, you may change speeds or feeds. You change your geometry. You're starting for front, back, and the radii. You won't even have to change because it's outer radius, right? So the outer radius is on stock OD. Now the bar is not gonna cut the stock OD. Basically, what it's gonna do is gonna scan all the geometry up to the stock OD, and it's gonna cut up to the geometry. Okay, it's not actually cut to the stock OD. So the largest diameter in that feature set is this diameter right here, where this chamfer is. Right? It's not gonna cut all the way up to the stock OD. Let's see. It still looks like it's taking a lot of material right there. So what we're gonna do is we're gonna edit. I'm gonna go to my radii right here, and we are going to here. Let's put this diameter. We're gonna put it at 1.5. So I'm gonna hit OK. Now notice my passes right here. So I'm gonna assimilate, click, and voila! Nice even passes, right? But anyways, so what you want to do is you want to have your radii on diameter. And you're going to put, so notice on the inner radius, what I did is I put an 1.5 inches. That's where the drill left. So that's where the material going to be removed starts, is at 1.5 inch. Clearance is just under that, right? Because the board bars will come in. When it backs up for clearance, it's going 100 thousandths below and coming out. But anyways, so I'm going to name this ID. So this is the first roughing. So the next thing we're going to do is we are going to rough out this little chamfer in the back, right? I'm going to use the same tool. So what I'm going to do is I'm going to select this ID rough, and I'm going to hit Control D for duplicate. And we're going to say, we're going to rename this ID rough back. I'm going to right click, I'm going to edit, and we're going to change the geometry. So the front, I'm going to put it on selection. I'm going to zoom in. I'm going to select this edge right here, right? And the back, I am going to put it in selection, or you put model back. Actually, let's do that. I'm going to put it on model back, and we're going to offset it. Let's start off at 100 thousandths. We'll see what that looks like. This may change. This may vary depending on how we actually. Sorry, gotta move this. So this may vary. We'll see what it looks like. Radii. So outer radius, we're going to put on stock OD. Inner radius, we'll put it on selection. I'm going to select this ID that we already roughed out. We'll have it on minus 0.1 clearance. I'm going to put it on selection. And we'll also keep it at minus 100,000. Now, the depth of cut, I'm going to put at 0.035. And grooving, I'm going to put on allow radial and axial. Now, notice I still have my stock to leave. All right. So I'm leaving the same amount of stock that I did on the original ID rough. And we're going to hit OK. All right. So this is how it came out. Now, one thing you could do is you go to edit on the radii right here. Instead of your stock OD right here, I'm going to put it on selection, and I'm going to select that actual edge right here. All right, so let's hit OK. Now, I got a better result doing that. That's because I limited how far up the tool could go, because I originally had it on stock OD. Now, usually that isn't a problem, but in this scenario, it actually is. That's because what we do is undercut. We want to have to kind of control or limit on how far up it could go, right? So this is good right here. Now, notice my original ID rough. We're going back minus 0.25. This one, we are going back not as far. Now, I didn't have to actually go back minus 0.25. It might be a little excessive, but I wanted to make sure I had enough room in there, right? But anyways, so that's my ID rough. So what I'm going to do now is I'm going to do a finish. So I'm going to go to Turning Profile Finishing. And let's see, my maximum spindle speed will go 1250. Geometry, I'm going to do model front. Back, I'm going to put on model back, and I'm going to offset it back minus 0.1, so 100 thousandths more. And on the radii, I'm going to do the save aim, my selection. I'm going to select back chamfer right here, which both these chamfers are the same size, the front and the back. So stock inner radius, I'm going to put it on selection, and we'll go minus 0.1 clearance, put it on selection, minus 0.1. Now, there's different ways to approach the radii tab, okay? But this will work right here. Now, I'm going to go ahead and hit OK. And notice that it didn't go up and cut that back chamfer. That's because I forgot to put the passes tab on allow radial grooving. Alright. Now that's correct. But look at this lead in right here. See how it leads in 45 degrees? What that is on my linking tab right here. I have use fixed lead in, but I have it set at 45, so I'm gonna put that at 0. This is just my preference. You don't have to do it this way. Let's go ahead and simulate this. Looks good. That's what we want. All right, so I'm going to name this ID finished. Now, notice I have a warning right here. So let's look at this warning. So X clearance trim at the clearance radius. So let's check that out. The radii tab loves having. Now, I'm going to be honest, this really ain't going to affect the toolpath, but we'll just fix it. Now notice, so I dropped down the clearance and the ID. Now the only problem is cutting air right there. Right? I don't like that at all. Let's change that back. There we go. Still cutting air. We'll offset it 25,000. All right. Tool comes up, comes in. All right. So we're not cutting air. That'll work right there. All right. We're gonna hit save. Okay. So the next toolpath is we're gonna part it off. Now, when we part it off, we're also going to add this chamfer right? Okay, so the next thing we're going to do is we are going to part it off, and we're going to also part off this 100,000 45 degree right here. That's 100,000. So you need to know if you want to cut it at an angle, you need to know the size thing. All right. But anyways, you should because you drew the part up to print, so you will have that. But just let you know. So, anyways, I'm gonna go to turning. I'm gonna go to turning part. And we're going to select a tool. Now, I already have a tool created, but like I said before in the other toolpaths, let's go ahead and make one so y'all know. So I hit the little plus sign right here. If that's not blue, select a document or select something that will allow you to add a tool. Notice if I click local, this is grayed out. It won't let me add a tool right there directly. I can add it to the library here. But anyways, in this case, I am going to do it in the actual file format, part file. But anyways, so I'm going to hit the plus sign, and we're going to use a turning grooving because that's what a part off tool is. It's basically a grooving tool. And let's make this a 0.125 wide part off with a R point, say 8,000 radius. So I'm going to do, so it's 125. Now, it helps to actually have the tool in front of you, so I'm going to be kind of guessing. Now, you want your tool to be long enough to actually part it off. That 1.2, that should be fine. My width, 0.125. Corner radius, type it in, 8 thousandths. Head length, not really too worried about that. My groove width, I'm going to make it match my width. I just find it easier, and I don't have to play around with settings. Setup, this should be fine right here. I'm going to leave everything default that I can. Surface footage, we'll go 350. Cutting feed rate, we go 2000ths. Post processor, yeah, tool number 8, whatever next tool it is. So I'm gonna hit select. I'm gonna go to my geometry tab. Back mode, model back. Offset, we're not gonna offset. Now edge break. This is what's gonna put the 45 degree on, right? So it's 100,000 chamfer. So I'm gonna put 0.1 45 degree, okay? Then I'm gonna go to the radii tab. Now look at the 45 right now. You got this blue line going all the way across. If you leave it like that, it's gonna be cutting air. We don't really want that. So what I'm gonna do is my clearance right here. I'm gonna go to selection. Go to select this outer diameter right here. I want the red. And we'll go to extra 50 thousandths. Retract, I'm going to do the same thing. There's other ways to do this too, so it's kind of preference on how you handle this. Make it 50 thousandths as well. Outer radius, I'm going to put it on selection. Probably should just leave it there, but oh well. And my inner radius, I'm going to put it on selection. I'm going to select this ID, and we'll offset it. We'll go additional minus 0.1. All right. Everything else should be fine. We're going to leave it default. I'm going to hit OK. And we're going to name this toolpath part off. And let's simulate it. So I'm going to simulate it. Tool comes down. Feeds in. And we're going to part it off. All right, guys. So that part off with the chamfer in this particular example isn't probably the best idea because you have these threads. And anytime you do a toolpath like that onto a thread, it tends to leave a burr back here. So really what I would do is go ahead and chamfer it with the V&M G335 rough after the rough. And then when you part off, actually just have it come in and feed straight down. That's the best way to do it right there. Then you don't have to worry about a burr. Okay. And when I say a burr, yeah, it is going to prevent the two mating parts from screwing together. Okay. So now you can always sand that off, or, use a file or emery cloth, but just do it the proper way. But that's about it, guys.